Assalamualaikum warahmatullahi wabarakatuh. In this video, we'll do another example of maximization or minimization using the Lagrange multipliers. So let me just get the question. Okay, so this question would be taken from final exam in the semester 2, 2018-2019. Okay, so so this would be last year, 18th of May. So there's, where is the question? Okay, so this is question 8. Okay, so let's just go through the question together. So question 8, 13 points. So you are given with a production function, which is in the form of Cobb-Douglas, right? A Cobb-Douglas production function, where to produce rice, we need to have both labor and capital. The wage for labor is $40 per unit, while the capital is $50 per unit, and the total input budget is 5,000. And let's say now the firm want to maximize the production of rice subject to the budget constraint. So we need to basically solve for the optimum number of units of labor and capital to be used, and then the maximum output to be produced. So let's just get the information. So we are given a production function, okay, Q, which is a function of which is now it's a production function which depends on two inputs, K, L, and then which equals to 20 L to the power of 0.6 and K to the power of 0.4. And then we have the budget constraint. So it was $40 for labor, right? So I'm just going to write $40 multiply with L, the number of labor that we use, plus, so each capital cost is $50. And the budget given to us is, we only have 5,000. Okay, so the question then asks for the, basically the optimal. So there are two questions, right? Optimal L and K, and then what is the optimal output? Okay, so let's just try to follow the procedures that we have discussed before. So step number 1, we simply summarize the information, maximize. I always like to write the variables of interest under this notation, maximize. So these are the two variables that we want to maximize. So we have F is our production function, depends on two inputs, labor and capital, subject to $40L plus 50K minus 5,000 equals 0. Okay, and then step number 2 will be to form the Lagrangian. Okay, now we have K, L, and lambda. So the first term would be the whole objective function that we want to maximize. So simply reproduce them here. L to the power of 0.6, K to the power of 0.4, plus sign, and then lambda, and then bracket. So write 40L plus 50K minus 5,000. So this would be our Lagrange equation, okay, for step number 2. Now step number 3, now we want to basically find the partial derivatives. Okay, we want to find the critical points. So how do we do this? So first we take the partial derivative with respect to L, okay, equals, so there is an L here, so let me just rewrite one here. And then this is L to the power of 0.6. Okay, since we have L to the power of 0.6, let me just, I don't know whether it's, I'm just going to write them in a different color, 0.6. And then we have L, but now to the power of 0.6, don't forget to subtract 1. Okay, and then have K to the power of 0.4 plus, there is an L here, right? So this one becomes lambda multiply with 40. And then we're gonna set this to be equal to 0. So this basically becomes 20 multiplied with 0.6 is 8. Sorry, not 8. It's 12. Okay, just try to erase this. And it should be 12, right? 12, and then I have my L here to the power of 0.6 minus 1 is negative 0.4, and then K 0.4 plus 40 lambda equals 0. And do the same now for capital. So capital would be 20, and then we have, okay, let me just try to basically maintain them in order. So 20 L 0.6, and then we have K. So my K here would be 0.4, right? This is the coefficient. And then I have my K to the power of 0.4, and then I have to subtract 1. Okay, subtract 1 here. And then plus lambda, because there is a K here, right? There is no K here, so this becomes 0. So multiply with 50. Okay, and this we're gonna make it to be equal to 0. So rewriting them, so 0.4 multiplied with 20, now this is 8, L 0.6, K 0.4 minus 1 would be negative 0.6 plus 50 lambda equals 0. And then the third equation, differentiate partial derivative. Find the partial derivative of the Lagrangian equation with respect to lambda. So there is no lambda in the first term. So we're going to basically rewrite the constraint. Plus 50k minus 5,000 equals 0. Okay, so now basically we have we have 3 unknowns and we have 3 equations. So we need to basically solve this simultaneously. Okay, we need to solve this simultaneously. Now, of course, there will be many ways how to solve this, but like what we have basically highlighted in the previous session, a good strategy, because these 2 variables multiplied, so it will be kind of difficult to complicated a bit if we want to solve for L and K and then substitute them in the third equation. So let me just number this. So this is equation 1, this is equation 2, and this is equation 3. Now, a good, perhaps a better strategy would be to solve for, so we're going to use, so use equation 1 and 2, solve for lambda. Okay, so let me just, I'm going to use this space now. So from equation 1, we're going to have 40 lambda equals, I'm going to bring all the other thing on the other side, 12 L. So don't forget the negative sign, 0.4, K 0.4, okay. And lambda here would then equal to negative 12 divided by 40, L negative 0.4, K 0.4, and this would give us, what is negative 12 divided by 40? This would be negative So don't forget the negative sign, 0.3. And then I'm just gonna write this in a elegant way where the variable with the negative power, I'm gonna put it in the denominator. So this is from equation 1, which is our lambda. What about for equation 2? Now 50 lambda equals, so bring everything to the other side. So don't forget the negative sign because I'm bringing this whole thing to the other side. So negative 8 KL to the power of 0.6, K to the power of negative 0.6. Okay, and so this would then give us, just right here, lambda would then equal to negative 8 divided by 50 L 0.6, K to the power of negative 0.6, which is 8 divided by 50 is 0.16. Use your calculator. And I'm going to put K in the denominator because the power is negative. Now that we have this, okay, 2 lambda, right? This is lambda, this is lambda. So we're going to make these 2 lambda to equal to each other. So lambda equals lambda. So what we're going to have here, okay, is that it's kind of hard to get the space on this side. Okay, so we're going to have, is it? So now this is negative and this is, okay, I missed the negative sign here. So don't try to avoid this mistake. There should be a negative sign here, right? Okay, equal to negative 0.16. So negative and negative. So I can basically, we can, so take note, this is negative. This is also negative. This is lambda and this is lambda. So they are the same. So we're going to basically equate these two. Okay, I'm going to put them here. So this would become so negative 0.3 K 0.4 L to the power of 0.4 would equal to negative 0.16 L to the power of 0.6 divided by K to the power of 0.6. Now, we need to simplify this. We need to solve for this. So what we're going to do is, so this is negative. So we can basically cancel this out. Negative and negative, they become positive. And the next step would be, this would be 0.3 divided by 0.16. And I'm going to basically cross multiply. Okay, cross multiply. This one, I'm going to bring this one up here. So K, so this would be K to the power of 0.4 multiply with K to the power of 0.6, which equals to, now there is no more negative sign, no more 0.16. I'm left with L to the power of 0.6. And similarly, I will bring this L to this side. So multiply with L to the power of 0.4. Okay, so from here on, we're going to have 0.3 divided, so 3 divided, 0.3 divided by 0.16 would give you 1.875. Use your calculator. So K, 0.4 plus 0.6, right? Since these terms they have the same base, so we can add their power. So 0.4 plus 0.6 would be K to the power of 1 would equals to L. So now we have solved for L in terms of K. So what we need to do next is to simply substitute L in equation 3, right? This equation. So we're going to have 40 L, which is 1.875 K, right? This is our L, plus 50K minus 5,000 equal 0. Now open the bracket, use your calculator. You should be able to get that. 40 multiplied with 1.875 would give you 75K plus 50K. Okay, I'm going to bring this 5,000 to the other side. negative 5,000, so become positive 5,000. So 75 plus 50 is 125k equals 5,000. So my k equals 5,000 divided by 125, which is 40. Now that we have solved the value of k, which is 40, so next would be to solve for, we need to solve for L. So L would then equal to 1.875 multiplied by 40, which is 75. Okay, so now basically we have more or less solved for, so this is our L and this is our K. K equals to 40. So K equals to 40. L equals to 75. What is the value of our lambda then? I'm going to leave this to you. Okay, you should be able to solve for lambda. And so basically, because the question asks for this, right? So we have basically solved that L equals 75, K equals to 40. So we need to employ, what is the meaning of these numbers? These numbers are basically the quantity of inputs, labor and capital that the company should use if the company really want to maximize the production. And how to find the production? We simply substitute this k equals to 40, L equals to 75 back into the original production function. So this is 20L. So L is 75 to the power of 0.6 and then multiply with k, which is 40 to the power of 0.4. So use your calculator and you should get something around 1166.52 something, I think. Okay, I think that's the right answer. Let me just double check that with my calculator. E to the power of 0.4. Yep, 1166.52. So for the second part of the question, basically the maximum output, okay, would be 1166.52. And that's basically how we solve, okay, for the this example taken from the final exam, one of the previous final exams. As simple as step one, or 4 steps. Step number 1, summarize the information. Step number 2, come up with the Lagrange equation. Step number 3 is where the actions are taking place. You need to find the partial derivative and solve for the variables. And then step number 4, make sure you give back what the information required by the question. So that's all for now. Thank you. Assalamualaikum warahmatullahi wabarakatuh.